Now the next thing is the threat modeling. So basically, what is threat modeling? Threat modeling is just a software process. It's the security process where potential threats are identified, categorized, and analyzed. This threat modeling can be performed as a proactive measure during the design and development or as a reactive measure once the product has been deployed. This process identifies the potential harm, the probability of occurrence, the priority of concern, and the means to eradicate or reduce the threat. When this modeling needs to be started, the threat modeling is not basically a single event, but it's a common for an organization to begin threat modeling early in the design process of a system and continue throughout its life cycle. A secure development life cycle process is required and that needs to be considered and implemented security at each and every stage of a software development life cycle. This supports the motto of secure by design, secure by default, and secure in deployment and communication, which we call it as ST3 plus C. It has basically main two goals to reduce the number of security related design and coding defects, to reduce the severity of any remaining defects. Now let's talk about the threat modeling stages. There are various stages this threat modeling needs to be applied. We have two approaches. One is a proactive approach and another is a reactive approach. Proactive approach to threat modeling takes place during the early stages of system development, specifically during the design and specification establishment. This type of threat modeling is also known as a defensive approach, where the design flaws are identified and secure principles are followed at the time of coding. This method is basically based on predicting threats and designing in specific defenses during the coding and crafting process, rather than relying on post deployment updates and patches. Unfortunately, not all threats can be predicted during the design phase. So, reactive approach threat modeling is still needed to address unforeseen issues. A reactive approach to threat modeling takes place after a product has been created and deployed. This type of threat modeling is also known as adversarial approaches. For example, running ethical hacking, penetration testing, source code review, and first testing. So these two approaches should be followed at the early stages. That is the first stage of identifying the defects and identifying the security threats and solving it. And once the product is ready, again we need to run some set of tools, which this set of tools can be taken from the recommended or NIST recommended tools, for example, penetration testing or an ethical testing tools. There are many industry standard tools are available today to run this kind of tests after the product is implemented and before it moves to the production environment. Okay, how do we identify the threats? There are a set of approaches. The approach one is basically it's a focused on assets. This method uses asset valuations results and attempts to identify threats to the valuable assets. A specific asset can be evaluated to determine if it is susceptible to an attack. If the asset hosts the data, access control can be evaluated to identify threats that can bypass authentication or authorization mechanisms. The second approach for identifying the threats is basically we need to focus on the attackers. Some organizations are able to identify potential attackers and can identify the threats they represent based on the attacker goals. For example, government is often able to identify potential attackers and recognize what the attackers want to achieve. They can then use this knowledge to identify and protect relevant assets. A challenge with this approach is that new attacker can appear that were not previously considered a threat. The third approach for identifying the threats is basically focused on the software. This is only for the software product. If an organization develops a software, it can consider potential threats against the software from the various departments. It might be a competitor who is trying to imitate the product, or it might be from the contractors or the trusted partners. So, an organization should have necessary controls to protect the software by using the copyrights or the licensing, or not disclosing the source code to any other third parties, or avoiding the reverse engineering process by not revealing anything proprietary information over the logs or anything.